Hi, I am Chandrasekhar Gupta and we are discussing programming concepts. Today our topic is iteration and recursion. We have written for, while and do while loops in which a specific task is repeated a certain number of times. This falls under the category of iteration. But what exactly was recursion? If you remember, we have written some code such as function so that it does some specific task for us. Similarly, if we want to pick up something, we can assign a specific person to it so that he does the work for us. But there are some special cases where you need to do the work by yourself. If you want to improve the score in the examination, you have to work and you have to do it yourself. The same concept is applicable in programming languages as well. There are some certain functions which has to rely upon itself for finishing or completing a specific task. Such function is called recursive function. And how do recursive functions exactly work? Let's have a look. Let's try to understand recursion with the help of this example. Consider this piece of code where I have an algorithm and it is calling itself when the value of n is greater than 0. It is accepting a formal argument, and if the value is greater than 0, it is calling the same function. We have seen calling the same function is actually possible, and that can be termed as recursion. So we have defined a main function over here and we have invoke the function with the help of this function call. I am passing 32 as an actual argument. We can actually trace this example with the help of two approaches. It can be solved with the help of a stack, or it can even be solved with the help of a recursion tree. We know that activation record or stack frame will be pushed onto the stack whenever a function call is made. That is a general approach how you solve any sort of problem. And recursion tree is generally used in some specific cases where you are having less number of statements inside the program. Here you can understand one thing. I have not included angular brackets or braces over here because I am having only single statement under this condition. So if you are having single statement, then the angular braces are optional. But if you are having more than one statement, then the angular braces are mandatory. First, let's try to look at this solution with the help of stack approach. A function call has been made from main function. So initially the main function will be pushed onto the stack. Now a function call has been made, a of 32, and whether it has been 32 is greater than 1. Yes, true. So it enters the conditional statement. Now the value of 32 will be printed. Again the function call will be made for the value a of n by 2. So a of 16, a function call will be pushed onto the stack. 16 will be printed, and it actually makes a function call for a of 8. 8 is greater than 1. Again the value of 8 will be printed. Now a of 4 will be called. A of 4 has been called. 4 is greater than 1. 4 will be printed. Now a of 2 will be called. So 2 is greater than 1 and 2 will be printed, and a of 1 is called. If you just see, now the value of n in this case is 1. So 1 is greater than 1. This condition is false. It comes out of this condition and it actually returns 0. So after returning the first one, a of 1 will be popped off from the stack. This will be no more. Now it will come to the execution of a of 2. We have finished the execution of a of 2 till this point. After this point, this function actually completes its execution and it will be popped off from the stack. So if you just observe, the function has completed execution in all these cases. All of this will be popped off from the stack. Now after the first call has been popped off from the stack, the control will be shifted to the main function. If we just observe, this is the output of this function. Now let's try to solve the same example with the help of a recursion tree. Let's assume in the main function, the function a has been called with a parameter of 8. So the actual argument is 8 and the formal argument is n, which is also 8 in this case. Initially a of 8 has been called, it enters the loop. Now this condition is satisfied. So the value of n is 8 here, so 8 has to be printed. Followed by that, a function call has been made to a of 4. Now this function call has been made, the value of n is 4 and the execution continues. Whether this condition is satisfied? Yes. Then it will enter the condition and the value of n, 4, has to be printed and a function call to a of 2 has been made. Even 2 is greater than 1. So 2 will be printed and a function call to a of 1 has been made. Whether 1 is greater than 1, this condition actually fails in a of 1, so it comes out of this condition statement and it returns 0. The execution ends here. If you just form this tree, it has to be traversed from top down and left to right. So I have to start from this point. It has to go from left to right. Now here the value of 8 has to be printed. So 8 will be printed first. Followed by that A of 4. This function call has been made. You can even form a stack here. At this point A of 8 has been pushed onto the stack. So A of 8 is present in the stack at this point. And 8 has been printed. Now at this point A of 4 has been pushed. So A of 4 is in the stack at this point. And here 4 will be printed. So 4 is printed. And again A of 2 function call has been made. So it will be pushed onto the stack A of 2. And the value of 2 will be printed. 2 has been printed. Finally A of 1 will be pushed onto the stack. A of 1 is pushed onto the stack. And the A of 1 execution has been completed at this point. So A of 1 will be popped off from the stack when the control flow has reached this point. Similarly, when the control flow has reached this point, A of 2 will be popped off. When the control flow reaches this point, A of 4, and when it has finished execution, even A of 8 will be popped off from the stack. Only main function will be remaining in the stack and the control will be shifted to the main function. So 8, 4 and 2 is the output of this program when a call has been made to A of 8. This is how the recursion examples are solved. Let's try to understand recursion with the help of one more example. I am taking more examples here so that if you understand recursion, you can solve the questions very easily when the concept is related to functions. Consider this example. Now, let's make this statement to n greater than 1. So, let's try to solve this initially with the help of a recursion tree. Let's say from the main function, we have actually called A of 8. Initially, A of 8 function call has been registered and it enters the condition. Now, A of 4 function call has been made. The control has been shifted to A of 4. Followed by that, it has to print the value of n. The n in this case is 8. So, 8 will be printed. And again, one more function call for A of 4 has been made here. Similarly, for A of 4, the condition is satisfied. The value of A of 2 will be called and 4 will be printed. Similarly, another function call will be made to A of 2. This is just a print statement, and when it comes to this function call, the same sequence will be repeated as both are the same function call. So, A of 2 will be called, 4 has to be printed, and then A of 2 will be called. Now, again, it satisfies the condition. A of 1, 2 will be printed. Again, A of 1 will be called. This is just a print statement. The same sequence will be repeated. 2 will be printed, A of 1 will be called, and here also the same structure has to be repeated. We know that if it is a recursion tree, it has to be traversed from top down and left to right. The execution starts here. It has to go from top to down and left to right. Initially, the value which will be printed was 2. So, 2 will be printed. Again, 4. 4 has to be printed. Again, 2. Now, 8. If you just observe from here, 2 A of 1 function calls will be made and 2 has to be printed. So, 2 will be printed here. Similarly, 4 will be printed. Followed by that, here also 2 will be printed and it completes the execution. This is the output for this recursive function. Similarly, we can solve the same example even in stack approach. We have solved a lot of examples using the stack approach even today and also in previous classes. If you have any doubt, just watch the video once again or refer to the video of functions where we have discussed about this stack function calls, or whenever the activation record will be pushed onto the stack, everything in detail. Now, after understanding recursion, you need to remember one more point. Iteration and recursion both are equal in power. That means the number of programs in the world that can be written under iteration can be written in recursion as well. A program can be written in recursion, can be converted to iteration as well. So, both of them are completely equal in power. And there is a disadvantage of recursion if you think deeply. Recursion actually makes use of function calls. So, a function call pushes an activation frame or stack record to the stack. Recursion is calling the same function again and again, and in turn it pushes the activation record onto the stack again and again. This actually comprises a lot of memory in the stack and leads to wastage in memory. But in iteration, memory is not being used. So, recursion is having a disadvantage when it comes to the usage of memory in stack. That's all for today.